Hello learners, this is Education Online program. I'm teacher Lily. I'm going to teach you chemistry, and our topic today is gas laws, and this topic is for senior 3 and 4. So learners, what is this gas law? So if we said gas law, we go back to the kinetic theory of gases, which state that the gas molecules are very small relative to the distance between their molecules. So because the kinetic theory have said that the gas are very small, or their molecules are very small relative to the distance between the molecules, that the molecules are in constant random and frequent collisions between each other. So they are small and their distance are very small, but they also have to move frequently or collide with each other at constant random motions. So with this clarification from the kinetic theory of gases, gases expand and contract with the changes of temperature and pressure. So we need to remember that gas, they are very small relative to their molecules and the distance between the molecules. So this makes them to have constant random motion and frequent collision with each other. So we can say that the gases, they can expand and contract with the changes of their temperature and pressure. So here the terms temperature and pressure are very important when we are dealing with the gas laws. So here we shall say that the gas law, because of this constant motion and collision with each other, they are going to be divided into 3 laws. So we shall have 3 gas laws, which can be the Bowles law, Charles law, and the combined gas law. Here, if we say combined gas law, it means we combine the Bowles law and Charles law together to give us the third law, which is known as the combined law. So we can put this one down by saying that the kinetic theory, so kinetic theory of gases states that the gas molecules so the kinetic theory of gases state that the gas molecules are very small relative to the distance between their molecules. So here we say that the gas law state that the gas molecules are very small relative to the distance between their molecules. So that the molecules are in constant motion. So these molecules, which are very small relative to their distance between the molecules, they are in constant motion and frequently collide with each other and with the walls of the container that they are kept in. Of course, we can't just have the volume or the pressure of a gas without putting it inside a container. So there is constant collision between the molecules and the container itself. So with this, we say that the gas expand and contract with the changes of temperature and pressure. The gases, here the gas expand and contract. The gas expand and contract with the changes with the changes of temperature and pressure. So if it means that as the molecules of the gas, they collide with each other and with the container, so it means that there is something, or there is a force that makes them to collide together. So in this case, we say the temperature and the pressure are the one responsible for the expansion and contraction of the gas molecules. So we said that this gas law is summarized into three laws, which are the three laws. The three laws of gases are Bowles law, Charles law, and combined gas laws. So we divide this gas law into three. We have the Bowles law, Charles law, and combined gas law. So with this, we need to know each of them. We need to know what is their effect on the pressure and the temperature of the container or of the molecules. So with this, we are going to take the first one as the Bowles law. What does it say? So you can take the first one as the Bowles law. So what does this Bowles law talk about? Here we say that the Bowles law, here it is discovered in the middle of the 60s and by a scientist called Robert Bowles. So he discovered that when volume of a fixed mass of a gas is decreased, the pressure of the gas increases. So here the pressure and the volume of the gas, they are going together. So when there is decrease in the volume of the gas, there is increase in its pressure. So when there is increase in the pressure, it means the volume decreases. So we can say that this law actually states that the volume of a fixed mass of any gas, at constant temperature is inversely proportional to its pressure. So it is inversely proportional to its pressure. When we keep the temperature constant and we change the volume and the pressure, then we shall say that this law is stated that the temperature is constant and the volume and the pressure, they are inversely proportional to each other. So we can say that the law is expressed mathematically as follows. So we can put this law as Bowles law states that at constant the volume of a fixed mass of a dry gas at constant temperature is inversely proportional to its pressure. It's inversely proportional to its pressure. So it's inversely proportional to its pressure. So the Bowles law states that the volume of a fixed mass of a dry gas at constant temperature is inversely proportional to its pressure. So learners, we need to note the changes here. When we have the volume of a fixed mass of a dry gas, it means of any gas, at constant temperature is inversely proportional to the pressure. So here the volume and the pressure, they changes. When you have increase in the volume, there is decrease in the pressure. When you have increase in the pressure, there is decrease in the volume. So this is the Ball's law all about. So we can have it mathematically as follows. The volume, which is represented by V, is inversely proportional to the pressure. So it's inversely proportional to the pressure, or we can say that V, which is the volume, is equals to the constant, which is K, and then over the pressure. So we can say that the Ball's law can be stated mathematically as the volume is inversely proportional to the pressure, or we can have volume equals to the constant, which is represented by K, and we divide it by the pressure, which is represented by P. So here we say that when we cross multiply volume with the pressure, we can have K PV is equals to K. So the pressure and the volume will be equals to the K. When we multiply the pressure with the volume, will give us the constant, which is K. So here we need also to derive that when this volume and pressure we multiply it and is equal to K, then this will be at constant temperature. So we have the temperature here is kept constant temperature. So we have this at constant temperature. So when you have this at constant temperature, then when pressure changes from pressure 1 to pressure 2, then we shall represent it by change in pressure which is represented by P1 and P2, which is pressure 1 and pressure 2. So when the pressure changes from pressure 1 to pressure 2, we are going to represent it as P1 and P2. So here also we can say that if there is changes in the volume, then we can have the volume changes from V1 to V2. So in this case, we represent it as volume 1 to volume 2. So this volume 1 is the original volume, and volume 2 is the final volume. The same as for pressure. Pressure 1 is the original pressure, and pressure 2 is the final pressure. So we are going to continue, and we need to come out with the final formula for this Ball's law. So change in volume, will be V1 and V2. So here we shall say the general equation is will be pressure 1 when we cross multiply pressure 1 and pressure and volume 1, then will be equals to pressure 2 volume 2. So here pressure 1 and pressure 1 is the original is the original pressure. Original pressure. And volume 1 is the original volume. Original volume. So we said pressure 2 is the final pressure. Final pressure, and volume 2 is the final volume. So learners, we need to remember that this is all the mathematical expression of the Bowles law. When we say Bowles law, states that the volume of a fixed mass of a dry gas at constant temperature is inversely proportional to the pressure. So we represent it by V, which is representing volume inversely proportional to the pressure, or we can write it as V is equals to the constant, which is K, and we divide it by the pressure. So here we are going to say that the gases, they are at constant motion, and they are frequently collide with each other and with the container that they are kept in. It means we are going to have changes in the temperature, changes in the pressure, and changes in the volume. So when there is change in the pressure, it means we are going to put it as pressure 1 and pressure 2. So we represent pressure 1 as volume, as pressure, original pressure, and pressure 2 as the final pressure. So we go also and say that the changes in volume, of course, as the molecules of the gas collide with each other, and we can say that the volume can change from volume 1 to volume 2. So here volume 1 the same as we said for pressure 1. We said the volume 1 is the original volume, and volume 2 is the final volume. So we are going to represent this equation generally by having P1 V1, which is the original volume and pressure, is equals to the final volume and pressure, which is represented by P2 and V2. So here we are going to also say that the pressure unit, the unit for pressure SI unit is Pascal, which is represented by PA. So but the standard one we are using is the atmospheric standard, which is represented by ATM. So with this we have to go back and say that we are going to know what is this Bowles law applied for. So we can have some application of the Bowles law, which is one of the gas law. So we shall say that the Bowles law have important application in one, we have filling of gas cylinders. Two, we can have popping of corn. So here this Bowles law is very important in the following two applications. First of all, the filling of gas cylinders and the popping of corns. So we need to remember that there are constant changes of the pressure and the volumes. So we have to have an example to verify this application of Bowles law. We can have an example 1. Example 1. We have the volume of a gas is 375 centimeter cube at a constant, at a pressure of 20 standard atmosphere. So what would be the new volume? What would be the new volume of the gas if the pressure is reduced to 15 atmosphere. So learners, we need to see this problem here is that the volume of a gas is 375 centimeter cube at a pressure of 20 atmosphere. So what will be the new volume of the gas if the pressure is reduced to 15 atmosphere? So in this case, we need to note down what are these values for. So if you say the volume, it means this here is representing the original volume, and we have pressure, and it is represented by 20 atm, which is the atmosphere. So you are asked to get the new volume of the gas if the pressure is reduced to 15 atmosphere. So here we are going to say that we need to put down the items. So we shall have volume is equals to 375 centimeter cube. So which volume is this one? We are going to represent it as the original volume. So here the original volume is represented by V1. So we are going to say V1 will be equals to 375 centimeter cube. Also here this pressure will be pressure 1. So we shall have P1 is equals to 20 atm, which is representing the unit for pressure. So let us look for the pressure 2 and volume 2. So what is required here is volume 2, which is unknown, and pressure 2 is 15 atm, which is representing that there is reduction in the pressure. In this case, we need to remember that the volume has increased. If the pressure reduces, it means the volume has increased. So we shall have So here we are going to see that what would be the new volume of the gas if the pressure is reduced to 15 atm. It means the volume has increased and the pressure decreases. So you remember the Bowles law, and it is always inversely proportional. Volume is inversely proportional to the pressure. So we are going to put down the formula is pressure 1 and volume 1. volume 1 will be equals to pressure 2 and volume 2. So this is the formula, and the three items there are provided. So we are going to put it inside the formula to get the value of the new volume. So we shall have that what is required is volume 2. So it means we cross multiply and we get the volume 1, volume 2 will be equals to pressure 1, volume 1 over pressure 2. So from here we are going to see that volume 1 is 375 and pressure 1 is 20. So we multiply by 375. So we divide by pressure 2, which is given 15. So when we calculate that one out, we are going to have a value which is giving us the new volume, which is the final volume. So we shall have to calculate that one out, and we shall have 500 centimeter cube. So this is representing the new volume. So the final volume, or the new volume as it has been stated in the problem there, will be equals to is 500 centimeter cube. So long as you have noticed that here we have 500 centimeter cube of the volume, and the original volume was 375. So here we have seen that there is increase in the volume. So what happened? We have seen that this is actually representing the Bowles law, because we said that the Bowles law at constant temperature, if there is change in the pressure, we shall have change in the volume. So it means if the pressure increases, the volume decreases, and if the volume increases, the pressure decreases. So with this we have seen that the volume has increased. It means that makes the pressure to decrease from 20 to 15. So let us have another example to make us familiar with the Bowles law. So we are going to have this one as an example, and you have to finish it out. So you know how to get the volume and the pressure, and you know that there is these two items, they are inversely proportional to each other. So we shall have a given mass of a gas occupies a volume of 200 centimeter cube at pressure of 5. So what is the new pressure? What is the new pressure if the volume of the gas changes to 800 centimeter cube? So learners, I will provide you with the answer, and you will have to calculate the answer. So the answer will be, it means the new pressure, which is pressure 2, will be equals to 1.25 A Tm. So you find out how do we reach to this answer. So learners, we have learned the gas law, and we said this gas law actually comes out through the theory or the kinetic theory of gases, and through the kinetic theory of gases, the gas law has been divided into three, and we say that there is Bowles law, Charles law, and the combined gas law. So we have known the Bowles law, we say that the volume and the pressure, they are inversely proportional to each other. So with these few examples, we have known how to calculate the volume or the pressure of the new gas, and we can come out through a formula which says pressure 1, volume 1 is equals to pressure volume 2 and pressure 2. So with this, you can also go out and find out the answer, which is put and it is 1.25 pressure 2, and you have to find it out by calculating through the formula which I've already given you. So thank you very much. I'm teacher Lily.